In my diagram, I've tried to capture all the information from the problem. I have a right prism container. The base has an area of 4 feet squared and the height is 5 feet. It's filled with water up to 3 feet deep. And I have a solid cube, and that solid cube has an edge of 1 foot. And of course, with a cube, that means all the edges are 1 foot. And we're going to drop it into the bottom of the container and try to figure out, when we do that, how much more will the water rise? That's our question. So the volume of the cube, right over here, is 1 cubic foot, because that's 1 times 1 times 1, 1 foot by 1 foot by 1 foot. And then we'll say, like, all right, let's have the number of feet that the water is going to go up will be x, and the volume that is more than, like that's above the 3 foot mark, will be 4 times x, because the area of the base down here will be multiplied by however much it actually rises, my x. So 4 times x will be the amount of water that rises when the cube is dropped in. It's actually a rectangular prism itself, one way to think about it. So if we froze it, it would be a rectangular prism. So we're going to multiply those together, and that will be equal to 1 cubic foot, because that rise in the water level was caused by putting that cube into the rectangular prism. When we solve this, we'll divide by 4 on both sides. That's the coefficient for the variable, and that gives me 1/4. Now we're thinking in feet, so the amount of the water rising is either 1/4 of a foot or 3 inches. So when we put that cube in, it will raise the height of the water 1/4 of a foot or 3 inches.